Cancer cells are characterized by altered metabolism, known as the Warburg effect, where they rely heavily on glycolysis for energy production, even in the presence of oxygen. This metabolic shift makes cancer cells highly dependent on glucose. Fasting induces a state of nutrient deprivation, leading to a significant reduction in blood glucose levels. This glucose deprivation imposes metabolic stress on cancer cells, which are less adaptable than normal cells to low glucose conditions. A 2022 study published in Nature Communications demonstrated that fasting-induced glucose restriction leads to the activation of AMP-activated protein kinase, also known as AMPK, which is a key energy sensor in cells. Activation of AMPK inhibits the mammalian target of rapamycin pathway, which is crucial for cell growth and proliferation. This inhibition leads to cell cycle arrest and apoptosis, or programmed cell death in cancer cells, while normal cells, which can utilize alternative energy sources like ketones, remain unharmed. Autophagy is a cellular process that involves the degradation and recycling of damaged or unnecessary cellular components. Research suggests that you'll have to fast for a minimum of 12 to 16 hours to induce autophagy. It plays a critical role in maintaining stable conditions in cells. During fasting, autophagy is increased as a survival mechanism in response to nutrient deprivation. This process can be particularly detrimental to cancer cells, which rely on preventing autophagy to avoid self-digestion and maintain rapid reproduction. A 2023 review in Cell Metabolism highlighted that fasting-induced autophagy leads to the degradation of oncogenic proteins and damaged organelles in cancer cells, promoting cell death. Fasting has also been shown to increase oxidative stress in cancer cells by enhancing the production of reactive oxygen species, ROS. ROS are highly reactive molecules that can damage cellular components, including DNA, proteins, and lipids. Cancer cells, due to their high metabolic activity, already experience elevated levels of ROS. Fasting further exacerbates this oxidative stress, pushing cancer cells beyond their threshold and leading to cell death. The immune system plays a crucial role in recognizing and eliminating cancer cells. Fasting has been shown to enhance immune surveillance by increasing the activity of cytotoxic T cells and natural killer NK cells, both of which are essential for targeting and destroying cancer cells. A 2024 study published in Nature Immunology found that fasting induces the secretion of cytokines that promote the activation and proliferation of T cells and NK cells. The study demonstrated that fasting increases the presentation of tumor-associated antigens on cancer cells, making them more recognizable to the immune system. Cancer cells often evade immune detection by creating an immunosuppressive tumor microenvironment characterized by the presence of regulatory T cells and myeloid-derived suppressor cells. These cells inhibit the activity of cytotoxic immune cells and promote tumor growth. A 2022 study in the Journal of Clinical Investigation showed that fasting reduces the number and activity of T cells and myeloid-derived suppressor cells in the tumor microenvironment. This reduction was accompanied by an increase in the infiltration of cytotoxic T cells into the tumor, leading to enhanced tumor cell killing. The study concluded that fasting could be an effective strategy to overcome immune evasion by tumors. Another way fasting helps kill cancer cells is by targeting cancer stem cells. Cancer stem cells are a subpopulation of cancer cells with the ability to self-renew and differentiate into various cell types. These cells are highly resistant to conventional therapies and are believed to be responsible for tumor recurrence and metastasis. Recent research suggests that fasting may target cancer stem cells, reducing their survival and reproductive capacity. A 2021 study published in Nature Communications investigated the effects of fasting on cancer stem cells in a mouse model of breast cancer. The study found that fasting significantly reduced the number of cancer stem cells in the tumors, leading to a decrease in tumor growth and metastasis. Now, certain foods can help to further promote autophagy to help starve cancer cells and promote cell death. They include green tea, which contains a polyphenol called EGCG that removes damaged proteins and organelles. Red grapes, blueberries, and peanuts also help promote autophagy as they contain resveratrol, which is a polyphenol that activates sirtuins, a family of proteins involved in cellular regulation, which in turn enhances autophagy. Curcumin has also been shown to induce autophagy and improve cellular health. Curcumin is the active compound in turmeric, and research indicates that curcumin can activate autophagy pathways that help in the degradation of amyloid plaques, which are associated with neurodegenerative diseases like Alzheimer's. Coffee, especially when consumed without sugar or cream, has been shown to promote autophagy. Compounds in coffee, such as polyphenols and caffeine, can inhibit mammalian target of ripamycin, also known as mTOR, and activate autophagy, particularly in the liver. Broccoli, Brussels sprouts, and cauliflower can induce autophagy as they contain sulforaphane, a compound that helps to eliminate damaged cells and supports the detoxification processes. Ginger has been associated with the induction of autophagy as it contains gingerol that can help in the clearance of damaged cells and support overall metabolic health. Cinnamon also contains compounds that have been shown to influence autophagy. Studies suggest that cinnamon can improve insulin sensitivity, which is associated with increased autophagy. Also, omega-3 fatty acids, found in fatty fish like salmon and in flax seeds, have anti-inflammatory properties and can promote autophagy.